Okay, so today let me cover another topic called delegates. Okay. Delegates are one of the, in my opinion, the neatest things in C#. Okay. If you, as you guys have taken a look at C#, most of it is similar to, let's say, Java or C++. Okay, there are a few things in C# that are different from other languages, and one of them is delegates. So, in my opinion, this is the part that makes this language probably better than Java or better than C++, right? So, why are delegates so neat? As I will demonstrate to you, delegates lead to what are called anonymous methods. Okay, anonymous methods lead to a concept called lambda expressions. Okay. Delegates also lead to a very neat event handling. So for example, if we click on a button or we select a menu, how do we know what should be triggered? As you will see, all event handling is done through the delegate mechanisms under C#. So anyway, lambda expressions further give us a very powerful concept called task parallel library. So it basically simplifies multi-threading. So we can write very efficient programs that take advantage of the multiple cores in our system. Okay. So anyway, let's take a look at what is the concept of delegates and what are anonymous methods, lambda expressions, and so on. Okay. So what exactly is a delegate? Delegate is simply an object-oriented form of a pointer to a function. Okay, so the job of a delegate is simply to point to a function, right? Once we are pointing to a function, we can make a call later on. So to give you a simple example, suppose you created a class called XYZ, and suppose you put something public double, let's say compute int A, int B. Okay, and you did some computation, you returned some result. Okay, so once you've written a class, if we wanted to point to this function, right, this is where the delegate comes into play. So first of all, delegate is a type, you know, just like class is a type, right? So remember we had discussed some time ago the concepts of types in the .NET system, and we had talked about, we have what are called value types, we have what are called reference types, right? Okay, what are value types? For example, standard data types, right? So for example, standard data types, int, double, byte, and so on, right? Value types, as you already know, are created on the stack, correct? Okay, what are reference types? Reference types are created on the heap. right? And what are the examples of reference types? For example, class objects. Whenever we allocate memory for an object of a class, we allocate it on the heap, right? Anybody remembers another type of reference types? Arrays. Arrays. Memory for arrays is always allocated on the heap, so arrays are reference types, right? What else? As we are discussing delegate, we will see delegate as a reference type. So that means once we create a delegate, the memory for it will be allocated on the heap, right? Okay, so now coming back to over here, you know, just like the class is just a template, meaning nothing exists in the memory until we create an object of it, right? So for example, let's say I have some double, let's say pi equal to whatever, 3.14, right? So the memory for pi is not allocated until we create an object of the class. As soon as we say xyz, x1 equal to mu xyz, right? This is where the computer will go to the stack area, okay, xyz, x1, it will create a reference called x1, right? Then new xyz, so how much memory will it allocate in the heap in this example? The only field we have is pi. So we'll allocate memory for pi. Okay, what else? Does it allocate some more memory in the heap? If you recall, it will also allocate memory for vtable pointer, which will further point to the vtable, which will further point to the type info, right? Okay, so just like we don't get any memory for the fields until we create an object of the class, very similarly with the delegate. So first we will declare a delegate, then we will allocate memory for it, right? So how do we create a delegate? The good news is, because the job of a delegate is to point to a function, creating a delegate is just one line of code, okay? Or defining a delegate as one line of code. So anywhere outside of a class, we can go and say, for example, if our goal is to point to this function, right? The signature of this function is double. Let me call it CDEL, short for compute delegate. Okay, then let me say int p, int q. So I'm trying to match the signature to the function that we are interested in pointing to. Okay. So once the signature matches, and we can call it anything we feel like it. We don't have to call it CDEL. We can call it MyDel or MDEL or CompDel, whatever you feel like it. Anyway, then the last thing you need to do is, just before it, you have to add the keyword delegate. So this one line of declaration, as you can see, will end up creating a delegate called CDEL, which is capable of pointing to a function that takes two integers and returns a double. Okay, so just like a class, it's just a declaration. Nothing exists in the memory. Okay, if we really wanted this delegate to point to this function, we have to create an object of it, right? So somewhere in our button handler or whatever, we may write this code. We may say xyz, x1 equal to new xyz. Then we will create one object of the delegate, new CDEL. Okay. Now we cannot leave the constructor of a delegate blank. You have to pick a function to point to. Okay. Since we are interested in pointing to the compute function, all you have to do is x1.compute. Okay. So as soon as we execute this line of code, what will happen? B1 is now pointing to this function. Okay, if our goal was to make a call to this function, we can simply say, for example, double result equal to D1 of 5 comma 7. Okay, so now this will end up calling this function, bringing the whatever the result is, and giving it to us. Okay. So to summarize, what is a delegate? Job of a delegate is to point to a function. Very simple, right? So it's like a pointer to a function. Okay, so then you might say, well, pointers to functions exist in C, C++. So what's new about a delegate? Okay, as I will demonstrate it to you soon, it is more than a pointer to a function. Okay, it has a lot more capabilities. So that's why I mentioned it's an object-oriented form of a pointer to a function, right? Delegate is a reference type, meaning once you want to use it, you have to create it on the heap. So take a look over here. Once we declare the delegate, we use the new keyword, correct? So that we can allocate the memory for it on the heap. And constructor for delegate cannot be left blank. You have to pick a function to point to. Okay. So notice we're not calling this function. If we were calling this function, there will be a left paren, right paren after the name of the function. We are simply pointing to the function. So that's why it's just the name of the function. No left paren, right paren after the name of the function. Right? Okay. So once you learn this concept, the natural question that will come to your mind is, it seems like a useless thing, because if the goal was to call this function, right, why even create a delegate? As soon as you create this, why can't we simply say x1.compute 57? Right? It will do the same thing. Everybody agrees? Yes. Okay, so why even create a delegate? Okay, and the answer is, for these simple situations, we will not create a delegate. This is a lot easier. But as I will show you, for more involved, more advanced situations, a delegate will make our life quite a bit easier. Okay. So anyway, we'll learn those situations where delegate makes a lot of sense. Okay. So second concept, after learning how to declare a delegate, by the way, let's pick another example. Let's suppose inside this class we have one more function, public void, let's say print info, let's say date time, dt. Date time is a pre-built class, right? So suppose we have one more function over here. Okay, if we wanted to call this function through a delegate, so for example, on your final exam, I'll give you quite a few questions related to delegates. Okay, so what if I said create a delegate that can point to this function and make a call to this function? Okay, so first thing you have to do is match the signature or the prototype of this function. So somewhere, okay, above the class you will say, let's try to match the signature first. So it is void, correct? Print info, you can call it pdel. You can call it anything, or print del, whatever you feel like it. And what kind of parameter it takes? Date time. Date time d. You don't even have to match dt. You can call it anything you feel like it. Once you match the signature, how do you convert it into a delegate? Just add the keyword delegate in the beginning. So now we have created a type called pdel, which is capable of pointing to a function that returns void and takes a parameter of date time, right? So if we wanted to point to this function, what will we do? We will create pdel p1 equal to new pdel. Okay, we've already created an object of the xyz class, so what will we say over here? x1 dot
print info.
print info. Okay, so now p1 is pointing to this function, right? If we wanted to call this through the delegate, what will our code look like? Sorry, p1
P1
datetime dot now. Now is a property of the datetime, which basically gives us current date and time. So now we can call this, and it will, whatever code we had written will get executed, right? So in this example, we have two delegates. Compute del is pointing to this function. pdel is pointing to this function, right? Okay, so now let me give you slightly more involved uses of delegates. Okay, so we can point one delegate to many functions, or let me say more than one function. Okay, so suppose we go and create a class. Okay, so suppose I say class my compute. Okay, suppose I put public double compute area, let's say double radius, and return math.py times radius. Okay, so that's one of the functions over here. Okay, so suppose I write one more function over here. Public double compute volume, double radius, and do a return math.py times 4.0 divided by 3.0 times radius times radius times radius. So 4 by 3 pi r cubed, right? So that will be, so let's pretend we wrote this class with two functions in it, right? Okay, now we wanted to create a delegate so that we can point to both of these functions, right? If we take a look at the signature of both of these functions, what kind of return do these functions give us?
Double.
And take a parameter of type double, right? So let's create prototype or to match the signature of the function we are interested in pointing to. So suppose I call it double, and suppose I call it comp del, and it takes a parameter double r. Okay, and how do I convert it to a delegate? Simply add the keyword delegate, right? You guys agree? And because delegate is one line of declaration, one line of code, okay, we can put it in the same file where we declared my compute above the class, or we can add another new file and simply put one line of code in it, okay? It doesn't matter because files in C# are not strongly associated with the code inside it, unlike Java. Okay. So anyway, once we have declared this, now suppose we go to our form in the button handler. Okay, we try to create one object of my compute. My compute, right? Okay, and now we try to create one object of the compute delegate. So comp del cd equal to new comp del. Can I leave the constructor of the delegate blank? No. So if you tried it, you'll see your code won't even compile. So I have to pick one function to point to, right? So let me pick the compute area to point to. So what will I write over here? MC dot compute area, correct? So now CD is pointing to over here. Everybody agrees?
Yes.
Okay, how do I make it point to the second function also? Okay, so the designers of C#, what they've done is they've overloaded the plus equal to operator. So using the plus equal to operator, you can point to as many functions as you feel like it. Okay, so if I do cd plus equal to new comp del mc dot compute vol. Okay, so now take a look over here. Now the same CD. So the same CD after we execute this line is also pointing to the compute volume, right? Okay, so now what if I try to do this? Double result equal to CD of 2.5. So can you guys guess how many functions will it call now? How many functions is CD pointing to? Two, right? Compute area and compute volume. So this will actually call two functions, right? So calls two functions. Okay, so the question is, what will be in the result? Will it be the result of compute area or will it be the result of compute volume? Because they both return different results. What's your guess?
Last one.
One possibility is the last one, right? Yeah. But then the question is, then what's the point of it? If we are totally ignoring this, what's the point of pointing to multiple functions? Okay, so let me give you the rule. If you try to actually compile this code won't even compile. Okay, why? Because if we are pointing to two different functions and those functions return something different, this code doesn't make any sense. Okay, so you should remember our rule is when multicasting is another term used meaning one delegate points to more than one function. So anytime you try to make the delegate point to more than one function, okay, the function has to return void. Otherwise, the code won't compile. Okay, so the way we wrote it, as I mentioned, because they are returning different results, it will not compile, right? So let's change it. let's change this to void. Change this to void. Then what do I have to do over here?
Void.
Make this void. Right? But can a void function return something? No. So the question is, we still want to know what did it compute, okay? So this is what we'll do. Inside this class, we'll create a read-only property. This function will modify the read-only property. So for example, let's do this. Let's create double, and let's call it area result equal to 0. And then public double area result get return area result. So I'm creating what's called a read-only property because it only has the get part in it. Okay? So now instead of doing the return, what will we do over here? We will say area result equal to math dot, right? Very similarly, I can create one more double, let me call it volume result equal to 0, and then public double volume result get return volume result. Okay, so once I've added one more private field called volume result and exposed it through a read-only property with a capital V, then what will this code change to? It will basically become vol result equal to math.py. Okay, so now let's go over here. So our first delegate that we created, we can make it point to compute area, which is fine. Second delegate using the plus equal to, we can make it point to the second function, right? Because both of these return void, we are satisfying the rule that anytime we try to make the delegate point to more than one function, that particular delegate or that particular function has to return void. Okay, so we satisfied the rule. It will be able to point to both of these functions correctly. Okay, so now let's try to make a call. Because the return is void, we'll make the call something like this, CD 2.5. Correct? So how many functions will it call now as soon as we execute this? 2, because it's pointing to 2, right? So each one of them will compute and store the, this will store the result in area result, this will store the result in volume result, correct? Vol result. So if we wanted to know the two different results, what do we have to do? We can simply say message box.show. Okay, name of the class object that we created was MC. We can call the first read-only property area result dot toString. Okay, so this will give us the result of the area plus MC dot vol result dot toString will give us the volume result. Okay. So to summarize, if we wanted one delegate to point to more than one function, what's the requirement? The requirement is the delegate should be of the type that returns void, because otherwise, if it was returning one particular value, we will not know which answer it will store, right? Okay, so anyway, now let's come to event handling, okay? So just like we can create our own delegate, like we created, for example, compdel, or like we created, for example, over here, a delegate for pointing to the print info, or delegate for pointing to compute over here, right? So just like we can create our own delegate, in the .NET library, there are many delegates that are pre-created, okay? And we can simply use them to point to whatever function we feel like it. Okay, so now let me describe the concept how event handling is done in .NET. Okay, as I mentioned, the fundamental mechanism for event handling, meaning you click on a button, what should we call? You click on a menu, what should we call? You move the mouse over, you right click, left click mouse, which function should be called? All of that is established through the event handling, okay? So the .NET library defines a delegate called event handler. Okay, and it is defined in a namespace called system. So most of the time we will say system.eventHandler because system is the namespace where this delegate is defined, right? How many lines of code we need to write to create a delegate, to define a delegate? One line of code. So the way this code is, or the way this delegate is defined in the library is, it looks like this. Okay, event handler is the name of the delegate. It takes two parameters. Okay, first is object. Okay, second is event args, which is a class already created in the .NET library. Okay, and what does it return? Void. So this is how this delegate is declared in the .NET library. Okay, so now let me ask you a question. Can we use this delegate to point to more than one function? And how would you know if a delegate is capable of pointing to more than one function? If the return is void, right? Okay, so suppose you created a form and you put two buttons over here, test 1, test 2. Okay, you gave it a name of BTN test 1. You gave it a name of BTN test 2. Right? Okay, so normally when you put a button, right, what do? You double click on it. Okay, once you double click on it, it takes you to the code area of the form, correct? And if you examine it, I'll go to the computer in a minute and show it to you. Once you examine it, what will it look like? It will look something like this: BTN test 1 underscore click. It will have a couple of parameters over here, right? And for example, you can write message box.show and whatever, hello, as an example. Okay. So now the question is, does it go by name of the button, underscore click, to know that if you click on this button, this should be called? Okay? Or is there some other mechanism that it uses to decide if you click on it, what should be called? Okay? And the answer is, you can call this function anything you feel like it. Okay? In fact, I'll go to the computer and change it to, let's say, suppose I call it test1 click. I take out the underscore. Okay. And now if I click on the button, you will notice it won't even work. Okay. It will not trigger this. Okay. And the reason is, whenever you double click on a button, remember we have two pieces of code, form1.cs, okay, and there's also form1.designer.cs. Okay, whatever event handlers we write go in this file. Okay, whatever button we create or double click, whatever Visual Studio is generating the code. So this is Visual Studio generated code. Okay, so if you examine the code, you will see there's a partial class form1 inherits from the form class, right? Same way, if you go to the designer generated file, you will also see partial class form1 inherits from the form and whatever code. Okay, so let me explain first the concept of partial classes. Okay, in C#, one class can be put into many files. This is totally opposite to Java. In Java, the file name is strongly tied to the class name. Okay, but in C#, if you have a large class, okay, you can create a partial class and say some of the code is over here. Then you can go to another file. So this is form1.cs, for example. And you can again declare a partial class. So what does that mean? This code plus this code, because both of them are partial class form1, this would be as if we wrote all of this code in one class. Okay, so the benefit of partial classes is that it sort of separates the code that Visual Studio is writing and the code that we are writing. Okay, otherwise it will be one giant mess. Okay. So this way, whatever visually you are putting over here, whatever properties you are setting over here, Visual Studio will keep generating the code in this file. Okay, our code is really the event handlers, so we can just focus on the event handlers, and that's why it's put in a separate file, and it's a lot cleaner. Okay, so anyway, so now let's pretend you double-clicked on this. What Visual Studio will do is we will go to the form1.designer.cs, and somewhere over here it will create this delegate, the system.event handler. Okay, so it will do something like this: system.event handler. Let's say EV1 equal to new system.event handler. Can we leave the constructor of the delegate blank? No. Okay. Actually, the real code is, because we double clicked on this btn test, right? So btn test 1 already has a delegate click plus equal to. Okay, so this click already is a property of type delegate of the system.event handler delegate. So as soon as you double click on it, what it does, it does a plus equal to on the click, which is a delegate of event handler type, and says this will be btn test1 underscore click. So Visual Studio generates this code as soon as we double click on the test1 button. Okay? So now what's the meaning of this? The meaning of this is if you click on this button, which function will be called? btn test1 underscore click, right? And that's why in the beginning this was called btn test1 underscore click. Okay, now let's say you don't like this name. You change this name to test1 click. Okay, so the reason it doesn't work is, even though you click on the button, nothing will get executed. Why? Because over here, where's the delegate pointing to? It's pointing to btn test underscore click. Okay? So once you know this is how the event handling works, to make this work, what will you need to do? You will need to go over here. Change it to what? Test1 click. And now if you click on the button, it will work fine. Okay. Now let's pretend the goal was something like this. Regardless we click over here or click over here, in both cases, we wanted this function to be called. Okay, so what if we go to the designer.cs, we copy this line and paste it below. Okay, and then what will I do? Make this btn test2.click plus equal to, and this stays exactly the same. So now what will happen if you click on test2? What's this delegate saying? Call this function, right? So it will call this function, okay? Now where, at this point in time, you may not see what's the point of having two different buttons called the same handler, okay? See, when we create user interfaces, okay, let's say you created a user interface where you have 0, 1, 2, and so on, 3, right? Okay, so let's pretend you were creating some kind of a calculator, like a scientific calculator, with 40 different buttons over here. How many event handlers will you need to write? 40, okay? But we can maybe break it down in two categories. Somebody is trying to type a number, or somebody is trying to click on an operation, right? Okay, so wouldn't it be nice if 0 through 9, including decimal, we tie it to one handler? Okay, so suppose you name these buttons btn 0, btn 1, and so on. Okay, so in the form1.designer.cs, what kind of code you will need to write so all of them go to one event handler? It will be something like this: btn 0.click plus equal to new system.event handler, right? And in the constructor, what will we do? Remember, event handler is the delegate. So in the constructor, we have to point to a function. So suppose we call it numeric key handler. So what does that mean inside of our class form 1? We have to have a function numeric key handler, correct?
Okay.
And remember it takes 2 parameters. And event args E. Okay, so anyway, so now as soon as somebody clicks on this 0, which function will be called?
This function.
This one, right? Same way, what if I copy this line? And suppose this is written once again in form 1 dot designer dot cs, right? Okay, so if I copy this line and say btn1 dot click plus equal to exact same thing, btn2 dot click, btn9 dot click, right? So now no matter which button you click, which event handler will it call? The numeric key handler. Okay. So now we want to, of course, know, did somebody click on these button 0 or button 1 or button 2? So this is where the first parameter comes into play. Okay, this will tell us who generated the event. So our code over here will look something like this. If sender is button. Button is a class representing all the buttons, right? Then we will say string name equal to button
Sender
and sender
button. Dot text.
dot name, for example. Okay, or we can say dot text. Okay, and we can say string text equal to, right?
Yeah.
And now we can say switch text and case 0. That means button 0 was pressed. Case 1, that means button 1 was pressed, and so on. Right? So this way we can centralize, or we can have a single event handler for many, many keys. Okay. Now, if you go to the computer and try this out, okay, suppose it works. No matter which key you press, you are able to trigger this common event handler, and it works, right? Now this is what you do. You add one more button over here. Let's pretend. Okay. Now you run the program. One thing you may notice is sometimes all of this code will disappear. So the 10 event handlers that you had tied to this common event handler disappear. Okay, why? Because anytime you change the user interface, what's Visual Studio doing? Writing to this file, correct? So it updates the file and it doesn't know that you were also trying to write something extra. It will recreate it and all your hard work is gone. Okay? So if you want to preserve this, you should not be touching the designer.cs. Okay, remember there are 2 classes associated with the form. One is the designer.cs. What's the other one? Our regular form CS. So any modifications you want to do, you should do it in the form.cs. This way Visual Studio will not touch your code. Okay? So where should we write this code then? Because we want this to be triggered right in the beginning.
Form 1 CS.
You can write it in the constructor of the form 1, right? So you will see in the form1.cs. Okay, there's a constructor public form 1. Okay, there will already be a call over there called initialize component. Okay, which basically generates all the UI text boxes and so on. If you put this code over here before, the problem is buttons haven't even been created yet. Okay, so obviously this code will throw a runtime error as soon as you try to run it. So where's the proper place for it? After the initialize component, so that all the event handlers have been created, right? Okay, so let me quickly go to the computer and set it up so that you guys know how the event handling works.